Good morning, all of you. My name is Janvi from BSc Chemistry Honors Final Year. Today, we are going to read the topic Uses of Organic and Inorganic Reagents in Inorganic Analysis. Introduction. Reagents are those compounds which are used in inorganic analysis for the detection and determination of ions in molecules. A large number of organic as well as inorganic reagents have been used for this purpose. The inorganic precipitating reagents generally precipitate the inorganic species as sparingly soluble salts or hydrous oxides. The organic precipitating agents form sparingly soluble products either through coordinate linkage or through ionic linkage between the inorganic species and the organic precipitating reagent. Advantages of using organic reagents. The advantages of using organic reagents are listed below. First, they are more specific than conventional reagents under certain conditions. Because of this property, they can frequently be used to detect a single type of ion in a complex mixture. Second, they can be more sensitive. Classical semi-micro methods of qualitative analysis which will usually not detect much less than 100 gammas of a substance under specific test solutions. Organic reagents, on the other hand, are capable of detecting below 10 gammas and in certain cases as little as 10 raised to the power minus 3 gamma. Third, they can be adopted in quantitative analysis. The organic precipitates are generally insoluble in water at a given pH and can be separated, dried, and weighed. Those reactions giving colored soluble products frequently show a regular change in color intensity with concentration of the substance under test and so are adaptable to an accurate comparison with colors representing concentration. This is the basic idea in the branch of colorimetry. Common properties of organic reagents. Some of the common properties of organic reagents due to which these are used in inorganic analysis are given below. First, formation of colored precipitate. A. Organic reagents form direct characteristic color with the ions to be detected. B. For locating endpoint, that is, as indicators employed in volumetric titrations. Second, formation of precipitate due to different difference in solubility. This may be made of on the basis of a gravimetric method. Third, extraction in organic solvent at controlled pH. 4. Masking reagents. This increases the selectivity of reagents. 5. Difference in volatility. 6. Oxidation or reduction to other valence state. 7. Wash liquids. The chemical nature of the organic reagent is important in determining the use of above mentioned properties. Advantages of organic reagents over inorganic reagents. It is due to the following properties that they are better precipitating reagents than inorganic reagents. First, selectivity. In many cases, organic reagents are somewhat specific. For example, cobalt from nickel using alpha nitroso, beta naphthol, or dimethylglyoxime. Aluminium from iron using cupferron, cadmium from copper using quinaldinic acid, and thiourea can be precipitated. In some cases, adjustment of the pH will often cause precipitation of one constituent alone. By changing pH and solvent conditions, one constituent after another can sometimes be quickly precipitated out. Second, ease of drying. Organic reagents produce compounds that have little affinity for water and are dried easily at temperature low enough to prevent decomposition. 3. Co-precipitation. Lack of ionic character of organic precipitation products greatly reduces co-precipitation in most cases. For example, the Co-precipitation of sodium and potassium with magnesium is much less when the latter is precipitated by 8-hydroxyquinoline than when it is precipitated by phosphate or oxalate. Some exceptions in metals do not do occur. It has been little studied, but in some cases it is as bad as inorganic precipitants. Reagents are usually insoluble in water, therefore, it is important not to add an excess of reagent. This is difficult because there is no way to tell when sufficient reagent without excess has been added. Any excess that is insoluble would add to the weight of the precipitate. Disadvantages of organic reagents. There are unfortunately disadvantages of using organic reagents. First, volatility. This is the first practical disadvantage of organic reagents because chelated compounds are non-polar. The forces between individual molecules in the crystal are not very great. The sum of the metallic complexes which are precipitated in analytical chemistry are appreciably volatile above 130 to 150 degrees Celsius and most decompose above this temperature. Therefore, the drying of precipitate should be done below 130 degrees Celsius to avoid decomposition. 2. Impurities in reagents. It is very difficult to prepare an organic reagent of the same degree of purity as, say, inorganic compounds. Impurities present in organic reagents may enter into the precipitate during the precipitation and cause undesirable reactions. For example, a dimethyl glyoxime exists in three forms, that is alpha, beta, gamma. Of these, only the alpha form is specific for nickel. While preparing dimethyl glyoxime, gamma form is also formed along with the alpha form. If the precipitation is carried out with this impure dimethyl glyoxime, then nickel will be precipitated with some other metals because alpha form is specific for nickel, whereas gamma form can precipitate other metals also. B. Ketoenol isomerism in such compounds are as dithiazone will cause errors in colorimetric work unless conditions are carefully selected. 3. Low solubility of the reagents in water. This is the greatest disadvantage which organic precipitants have in comparison with inorganic precipitants. 4. High molecular weight. The very high molecular weights of chelate complexes formed with the metal ion reduce proportionality, some small errors in precipitation and weighing. 5. Colored compounds. Chelate compounds are often highly colored, and since they are usually soluble in inorganic solvents, they lend themselves to colorimetric or photometric methods of analysis. 6. Solubility of organic solvents. Because of their covalent nature, most metal complexes with organic reagents are soluble in non-polar solvents. Chloroform being usually the best, such solvents are used to extract the complexes for colorimetric determination, or they may be used simply for separating one element from another. Thus, the complex of cupferrin with tripositive iron is very soluble in ether and chloroform, which allow one to remove large amounts of iron from solutions containing aluminium. In these extractions, the pH must be carefully adjusted to give the desired separation. Important organic reagents. Some of the organic reagents which are generally used in the identification of ions are discussed below. First, oxime C9H7ON. The structure of this reagent is given. It is almost a colorless solid solid soluble in organic solvents and mineral acids. It gives yellow color which may be due to the formation of cunoid structure. It is introduced by Hahn and Berg in 1927 as analytical reagent. A number of metals give coordination complexes with this reagent. Examples of such metals are magnesium, zinc, copper, cadmium, lead, aluminium, iron, boron, gallium, thallium, zirconium, etc. The formation of the complex compound with a bivalent metal ion like Zn2 positive is shown below. The qualitative estimation of the complex is carried out by drying and weighing the hydrated or anhydrous complex or complex is ignited to oxide and then weighed. In volumetric methods, the precipitate is dissolved by filtering with hydrochloric acid and then resulting solution is titrated against standard potassium bromide solution. In spectrophotometric method, the estimation of the metal ion is carried out by measuring the optical density of the complex. The reagent has been found to be suitable for magnesium, aluminium, etc. The reagent is a 2% solution of oxine in 2N-acetic acid. 2. Dimethyl This reagent was discovered by L. Teshinkoff 1905 and applied by O. Brunk 1907 for the determination of nickel in steel. The structure of this reagent is shown in figure 18.2. This reagent gives an insoluble red chelate with nickel 2 positive ion in ammonical medium. For details, see applications of the formation of chelated complex discussed in chapter on basic concepts of coordination chemistry. Chapter 1. Solution of palladium salts gives characteristic yellow precipitate in dilute HCl or H2SO4, but nitrate ions interfere. Solution of bismuth salts also gives a yellow precipitate in presence of EDTA at pH 11.0 to 11.5. For the studies, 1% solution of the dimethyl in alcohol is employed. In spectrophotometric method, the insoluble precipitate is extracted into chloroform which yields yellow coloration and then the optical density is measured. 3. Alpha nitroso beta naphthol, also called 1 nitroso 2 naphthol. The structure of this reagent is shown at A of figure 18.3. It is an orange-brown powder having melting point of 109 degrees Celsius, soluble in organic solvents but almost insoluble in water. This reagent is usually employed as a saturated solution in 50% acetic acid. This reagent is common for the precipitation of many metallic radicals, but it is used specially for the detection of ferric iron, copper, and cobalt, with palladium and uranyl salts in slightly acid solution. It gives insoluble colored compounds under suitable conditions. Nickel and magnesium, however, are not precipitated by this reagent. Therefore, the reagent in acid solution is used for the separation of nickel and cobalt. Nickel from cobalt. The structure of the chelated complex formed by the reagent with cobalt 3 positive ion is shown at B of figure 18.3. The reagent has also been used for the spectrophotometric determination of cobalt and a few other metal ions. It is also used for spot test of cobalt. 4. Cupferron. Cupferron exists largely not in the nitroso hydroxy form A but in a tautometric amine oxide form B. Figure 18.4. The reagent is usually employed as a 6% aqueous solution but is most useful in strongly acidic solution. In strongly acidic solution, it precipitates Fe3, Ce3, Nb, Ta, W6, Ga, and SN2, Cu2, etc. Precipitates should be filtered immediately after their formation because cupferron is not very stable in acid solution. Furthermore, precipitation should be carried out in cold since the reagent is decomposed into nitrobenzene on heating. The precipitates cannot be weighed after drying but must be ignited to the corresponding oxide and then weighed. The formation of the chelated complex with Cu2 positive ion can be shown as follows. 5. Aluminon. It is a ammonium salt of orine tricarboxylic acids. Its structure is shown in figure 18.5. It is a brownish red powder freely soluble in water. It forms brilliant colored lakes with certain metals, especially aluminium, with which it gives a bright red lake. Aluminon is a dye and it is very important reagent for spectrophotometric determination of aluminium. By adjusting pH of the rest solution below 7.8, it is possible to estimate 0.005 milligram of aluminium even in the presence of calcium. The reagent is prepared by dissolving 0.1 gram of the substance in 100 ml of water. 6. Rubinic acid, also called dithioxamide. This reagent is the diamide of dithioxalic acid and is an equilibrium mixture with its tautometric acetimido form. The Ac form combines nickel, cobalt, and copper to give colored water insoluble in a complex salts whose composition is shown in figure 18.6. The copper, cobalt, and nickel compounds are quantitatively precipitated from strongly ammonical solutions. In strong mineral acid solutions, rubinoic acid reacts only with certain elements of platinum salts. In addition to above, rubinoic acid forms colored compounds with silver, mercury 1, bismuth, and iron 3. Rubinoic acid is not only important as spot test reagent but also as a gravimetric and spectrophotometric reagent. 7. Rhodamine B. It is tetraethyl rhodamine and is represented by the structure of given in figure 18.7. Solution of antimony 5 salts in strong hydrochloric acid reacts with rhodamine B and the aqueous solution of the reagent changes from red to violet or blue and finally divided precipitate separates immediately or after standing. Trace amounts of antimony may be detected in the presence of large quantities of tin by means of this reagent. Small amounts of iron do not interfere. Mercury, gold, palladium and are precipitated while molybdates and tungstates in acid solution give color reactions with rhodamine B similar to those given by antimony salt. The freshly prepared benzene solution of the rhodamine B is preferred to the aqueous solution. 8. Benzidine. Its structure is given in the margin in figure 18.8. It is a basic reagent and is employed in slightly acidic solution as dihydrochloride for the precipitation of sulfates as C12H12N2H2 whole 2 positive SO4 2 negative. The resulting precipitates may be titrated against standard alkali. The important drawback of the method is the relatively high solubility of the precipitate in water and even more in dilute hydrochloric acid. It also precipitates anions like phosphates and tungstates and give crystalline precipitates with a number of metallic ions such as silver, copper, cadmium, gold, zinc, etc. With copper 3 and Tl3, benzidine yields a blue coloration in alkaline medium, which is an important spot test for the metal ions. Recently, benzidine in dilute acetic acid has also been employed as a spot test reagent for the identification of some platinum metals like osmium, iridium, and platinum. Cupron or alpha benzoin. Its structure is given in figure 18.9. It is a white crystalline solid. It is sparingly soluble in water but fairly soluble in alcohol. It also exists in isomeric beta form. Cupron is used as a reagent for the quantitative determination of copper, molybdenum, and tungsten. Alcoholic solution of cupron gives a green precipitate with ammoniacal solution of copper salt. Precipitation of other metals in ammoniacal medium is prevented in the presence of tartaric acid. The green precipitate is soluble in dilute mineral acids. Copper can be estimated both volumetrically and gravimetrically by this reagent. The green precipitate is an inner complex whose formation can be shown as cupron also precipitates molybdenum and vanadium ions quantitatively, but in strongly acid solution, vanadium gives a yellow precipitate, while molybdenum gives a white precipitate. Tungsten and palladium also appear to be quantitatively precipitated with alpha benzoin oxime. Phil et al. Have recommended the use of the reagent for the detection of basicity in slightly soluble materials such as Al2O3, BaCO3, etc. 10. Magnesium. The structure of this reagent is given in figure 18.10. It is also called para-nitrobenzene azoresorcinol. 1 to 0.5% solution in 0.25 normal in NaOH is generally employed. In alkaline solutions, it forms a bright yellow lake with magnesium ions. The sensitivity of this test is influenced by the presence of ammonium salts, so their presence must be avoided. 11. Alizarin S. It is alizarin sulfonic acid whose structure has been shown in figure 18.11. It is a dye whose sodium salt is soluble in water and is employed as an analytical reagent. Aluminium salt give a red precipitate with the violet solution of alizarin S in ammonia. This complex is a adsorption complex of aluminium with alizarin sulfonic acid. As adsorption system of this type containing metal hydroxide and a dye stuff are called lakes. Zirconium 4 forms red violet colored compounds with the reagent under the alkaline condition. Boric 4 forms red violet colored compounds with the reagent under the alkaline condition. Boric acid also forms brilliant red color in UV light by alizarin in H2SO4. The reagent has been employed as a spectrophotometric reagent for the above metal ions as well as for few other. Furthermore, its applicability as adsorption indicator in the titration of FeCN6 hole 4 negative, molybdenum O4 hole 2 negative has also been reported. 12. Nitrone. Its structure is given in figure 18.12. It is a yellow solid. It is insoluble in water but dissolves in acetic acid. Its 10% solution in 5% acetic acid is generally used as a reagent. Nitrone with nitrate yields a sparingly soluble crystalline nitrate C20H16N4.HNO3 in solution acidified with acetic or sulfonic acid. Thus, nitrone is a gravimetric reagent for nitrate. Perchlorate, perrhenate, tetrafluoroborate, and tungstate also form insoluble salts and can be determined in a similar manner. Numerous other anions including bromide, iodide, chlorate, thiocyanate, nitrate, and chromate interfere but may easily be removed by preliminary treatment. The results in the presence of chloride ions are generally high, possible because of co-precipitation. 13. Salicyl Salicyl aldoxime. The structure of this reagent is given in figure 18.13. It is a white crystalline solid melting point 57 degrees Celsius, sparingly soluble in water. 5% solution of the salicyl aldoxime in 50% ethyl alcohol is used as a reagent. The reagent decomposes in solution and should not be kept for more than about 30 days. Salicyl aldoxime gives a yellow greenish precipitate of the inner complex of copper salicyl aldoxime with acetic acid solution of Cu2 positive ion. Important inorganic reagents. Some important inorganic reagents, precipitating reagents, are listed in table 18.1. Some common precipitating reagent. Precipitation of Al3 positive, Ca2 positive, and magnesium 2 positive ions by liquid ammonia, oxalic acid, H2C2O4, and NH4 HPO4 respectively can be shown as Al2SO4 plus 6NH4OH gives 2AlOH 3 plus 3NH4 2AlOH ignite minus 3H2O gives Al2O3 plus 3H2. MgSO4 plus NH4 HPO4 gives MgNH4PO4 6.6H2O plus NH4HSO4 2MgNH4PO4.6H2O with ignite gives Mg2P2O7 plus 2NH3 plus 7H2. Thank you.